Hello, EcoAct students. My name is Amma, and this is VJ, and today we are going to be talking about biomimicry. So we're going to start this lesson off by just taking a minute to think about problems that we've had in our own lives. So I'm just going to pause the video and just take a minute to think about problems that you've had. So one man, when he was hiking with his dog, kept getting burrs on his pant legs, and his dog's fur had burrs all over it, which is pretty annoying. And so he was like, let's take a look at this. Why does it keep latching on? So he takes a microscope and goes to a carpenter, and they look at it really, really closely, and there's tiny little hooks. And you might not have guessed it, or maybe you did, who knows? But that was how Velcro was created. That is how people use biomimicry to create new solutions for problems. So the Velcro that might be on your shoes, it came from burrs. So here's another example of how we use nature to solve our own problems. This is the Shinkansen bullet train. Now, let's take a moment to think about what inspired this. So the train seems to have a pointed front, kind of like, what bird? Did you think of the kingfisher? Well, if you didn't, do you see the similarity between the two? It has a nice pointed beak, which makes the train go even faster and more quiet, which is really good and solves the problem of loud, super duper fast, noisy trains going through your neighborhood, because I don't know about you, but I don't want to hear that when I'm trying to sleep. Another example is the tree canopy. So this is a design for buildings where you want to have nice, cool shade, especially when you're outside, but you also want the light to come through. So these tree canopies were modeled after real tree canopies to let in sunlight, but to keep the area nice, cool, and shady. Now, let's look at one more example. These are called inflatable resilient structures and are designed off a special type of molecule called nomocells. So you can create these in any way. So see how there's different shapes here, and these two are different shapes. You can create a whole bunch of different types of structures, which is really good for events. And here's another example of a structure that was built using these cells. Now, let's take a moment to think about what all of these inventions, that is, the bullet train, the tree canopy, and the inflatable resilient structures. So let's take a moment to think about what all of those inventions have in common. Now I want you to go to the Google form and write down what you think they have in common. As you might have guessed, all of these inventions were inspired by nature, and that is what we're about to learn more about today. So let's learn a little bit of vocab. All right, biomimicry vocab. The first word is biomimicry, which means to learn from and then emulate, meaning to replicate biological forms, processes, and ecosystems to create more sustainable designs. So, you see the burrs here? These are the burrs that I was talking about earlier that latched onto the dog's fur. Those burrs, in turn, inspired Velcro. These traits and functions we find in nature have specific uses that we can replicate in technology to help innovation be even more efficient. Another example are these robotic arms. Maybe you've seen something similar in maybe Spider-Man, which were inspired by an elephant's trunk. Biophilic design means to design a structure to be more involved and connected to nature. And there are different ways that you can do this. Some might be incorporating nature and plants into your architecture and infrastructure. So for example, this area has a planter with a whole bunch of plants. So that's one example of biophilic design. Another would be to actually incorporate nature into your building. So there's green pathways and also some green shrubbery in the background. So this incorporates both types, meaning both the actual architecture and just the area. So these are analogous structures, and analogous structures are structures that look similar but come about in different ways. So all of these structures have similarities but are different. Here's an insect leg, but here's a horse leg. I think it's pretty safe to say that they're both different. In the animal comparison diagram, the animals compared have similar yet different traits. In the bone diagram, you can see that human, cats, whales, and bats all have the same type of bones in our arms and our hands, but our limbs look very different in comparison. All right, here's another word, biologize. To take a human need or function and rephrase it so that an answer may be found in biology. An example of this is studying the texture and dynamics of shark skin, which led to scientists figuring out how to make an aerodynamic material pattern that can also prevent bacterial colony formation. And both shark skin and the antibacterial pattern are shown very close up. So, do these two look similar? See how they both have long ridges? That's an example of how to biologize. Now that you have a good example of the vocabulary, go back to the Google form and answer a couple questions about them and see if you can apply what you've just learned to some new concepts. When you're done, come back to the video.
Okay, now it's you guys' turn to come up with some different examples and ideas and activities, so now you guys can become the scientist. So there are a few different examples that you guys could work off of, like a cactus in the desert that has deep roots that gathers water. That could be a really great invention for, I don't know, farmers, for when it's a drought season and they need water that's stored underground. Or bird's wings that can move so well in the air. That could be a great design for a plane or a helicopter. So now I would love for you guys to go over to our Google Forms, and there you can tell me your problem and you can give me your solution. So you guys can come up with anything, just tell me the animal or the plant that it is mimicked after, and then your solution of how you would do it or solve it.
All right, let's go over our vocabulary one more time to make sure we've got it. Biomimicry means learning from and then emulating biological forms, processes, and the ecosystems to create more sustainable designs. Biophilic design, designing a structure to be more connected to nature. So think back to building with nature. So having maybe grass pathways or a bunch of planters for nice, beautiful, nice smelling plants. Analogous structures are structures that look similar but come about in different ways. So for example, the horse leg and the insect leg, or maybe a cat arm and a human arm. Same parts, different look. Biologize, to take a human need or function and rephrase it so that an answer may be found in biology. An example of this would be shark skin and aerodynamic material. All right, now that we've redefined our today's vocabulary, let's go back to the Google form and answer the conclusion section, which has 3 questions.
Now, to leave you off with something to think about, I want you guys to look at your surroundings, outside your window, maybe inside at your pets, and apply what you learned today and your new vocab words to your surroundings. See if there's anything that might strike up an interest that you learned today. See if maybe your cat has a few special skills that would be helpful in the world.